Alright, so problem number 43. I have to get my little picture here. It says that there's a force applied to a radio-controlled model car that moves parallel to the x-axis in a straight line or on a straight track, with the x component of the force varying with the x coordinate of the car. So sorry, this is x, which is in meters, and this is F, which is in newtons, I believe. Yes. Okay. So, with this car, there are E parts. So, A, B, C, D, E. 5 parts to this one. Fun. Okay, so each of these should be pretty easy, though. So, A, B, C, D. That's a B. I can write. I'm not totally illiterate. Not totally. And E. So I'm not leaving a lot of space for these because these are pretty graphical answers. So for part A, it wants us to figure out the work done when the car moves from 0 to 3. So this is pretty simple because all you do is work equals the integral of force over distance. And when force is constant, you can just ignore the integral, but here it's not. So we just sum up the integral, or the area between the x-axis and the curve, or the line in this case, and then multiply it by a distance, basically. So, or over, it's pretty simple. You're just integrating force, basically. So from 0 to 3, is it, right? Yeah. So you just find the area in here underneath the curve here, because this is from 0, which is right here, to 3. So you find all the area between the curve or the line and the x-axis. So right here, the easiest way to do this is to split it up right here along the number 2 on the x-axis. So you get a triangle of base 2 and height 2. So 2 times 2 divided by 2, because it's a triangle, equals 2 plus 2 more because you just have 2 boxes here and here, equals 4. So that is 4 joules, because units are important. Okay, so that is the first part, so we can get rid of that. And then the second part, part B, asks between 3 meters and 4 meters. So right here, there's no area between the line and the curve between that, so 0 joules. Part C asks something else, which is x equals 4 to x equals 7, so from here to here, and we only have this little area here, so this is a triangle with a base 2 and height of -1, so 2 times -1 equals -2, divided by 2 equals -1, -1 joules. Because negative work is being done to it because the force is being applied opposite to the direction of travel. So this is basically slowing it down. And then the next part, part D, asks from 0 to 7, so that's along the entire thing. So now, if you noticed, from these first 3 parts, we have from here to here, and from here to here, and from here to here. And so from here to here is going to be the same as summing all of these. So instead of going through and doing all the geometry again, we can just add up these things here. So 4 plus 0 plus -1 equals positive 3 joules. So that's pretty simple, and then it asks us to do it from 7 to 2 meters. So the important thing here is that we are moving this way, which means that is opposite to the direction of travel. So this is automatically going to give us a negative number. So you have this part here, which we already calculated out to be negative, just -1, right? And then plus, I'll go ahead and put this in parentheses, in this area here, from 3 to 2, because this area is 0, so we can ignore that. So from 3 to 2, we have 2, because you can draw in the boxes, basically, and there's 2 boxes. And then if you factor the negative in, you get 1 minus 2, which equals -1. So that is our answer for E, -1 joules.